So you might think, how can you get any form of corrosion at all inside a gearbox, which is full of oil and gears all thrashing about and splashing oil all over the place? Well, the only place there isn't very much oil is in the middle of this shaft, which is hollow and open to the air at the top, which is a pressurization thing, and it could be sealed, but it would be a difficult thing to do, and there's never really been a need. It's not normally a sealed part. So this inside here is open to the atmosphere. Now the gearbox gets pretty hot when it's in operation. They routinely run about 85, 90 degrees centigrade when they're running, and obviously at the end of flight they cool down. So you've got a possibility for condensation. So that's potentially where water is getting in, but it doesn't matter if there's nothing to trap it. And at the same time, there's oil being sprayed up from the bottom because there's some gear splines within the shaft to lubricate those. And what became apparent was the oil being sprayed up here wasn't man enough for the job. It wasn't actually able to keep the whole part sufficiently covered in oil to keep moisture out, and that's what allowed moisture to be trapped. As I mentioned before, this shaft rotates pretty quickly. It's not the fastest rotating part in the gearbox, but it's rotating at 2400 RPM, which means that the centrifugal loads inside the shaft are about 400 G. So there's an awful lot of force to press any moisture which is trapped outwards against the surface. And the things that allowed the moisture to be trapped are there's some slight wear on these gear splines which are in here, which creating a sort of a metal paste. There's oil in there as well, and you get this slight sludge and paste, and this was trapping the moisture within it. And then there are some slight machinings, some grooves, which were to do with the weld, which allowed that paste to be pressed up and held in place while the aircraft was in flight or the part was rotating. So this allowed water to be trapped up against the surface or the inside surface of the shaft for long periods of time. And that, together with latent stress in the world, which isn't in every single gearbox, it was just in a few of them, and the other stress concentrators due to the design and shape of the part at the time, allowed all these things to be added together to allow a crack to develop and then to propagate. But the key factor is, for any of this to happen, you have to have the moisture here and trapped against the part. Which brings us to the solutions. The immediate solution is fairly obviously to remove the moisture. So what's being done is the oil jet is being added to and redirected. So there's an additional jet to ensure that all of the area down here and up to these gear splines is much more adequately or properly covered in oil. I mean, now it's going to be drenched in oil, so there's no possibility for moisture to remain. And again, that's the biggest hole in the Swiss cheese. Once that's removed, everything else isn't really particularly relevant. So there are other safety measures on top of that, but that's really the key one. And before we any kind of return to flight, the interior of all these shafts are all being cleaned. I mean, to be honest, we've not found very much contamination there. I mean, even having sludge or any of this paste inside the gear shaft is pretty unusual. It wasn't an area that was looked at very closely in the past. It was something that had been looked at every 500 or 600 hours as part of a more major inspection. And even when we've done that, we've not found very much sludge there. And now that we've cleaned them all, we didn't have to clean very much off. There wasn't very much on any aircraft. So there's a number of unusual events that sort of came together to allow this to happen in the first place. A longer-term solution is a redesigned shaft, which is, so I don't really see it from this picture actually, but if you see the real shaft, it looks a lot smoother. There are far fewer of these ridges and things to trap moisture when it's spinning really fast. There are additional holes so you've got an increased thickness, so you've got a stronger part, and then you've got some more holes in it to allow greater lubrication through the oil jets that spray through these holes. So that's the longer term solution. And so in the meantime, so these are cleaned. They're cleaned on a more regular basis if we need to, and the oil jet has been redirected so that there's a lot more oil washing around inside. And because we understand the cause and we understand the importance of the moisture, that's why the existing shafts are safe with these current safety measures. So we've fixed the problem, and that's why it's perfectly safe to go flying now and not wait for this shaft, which has yet to go through the full design process, certification, flight testing, and all the other things it'll have to do before it can be fitted to the aircraft. But this is still worth having, because at the moment we are having to do these additional inspections, and that they will no longer be required with this part. So there's an engineering burden on nightly inspections, which will no longer be required once this is in place. So it's still worth having the new part, but in the meantime, we're good to go with what we've got.